area of triangles. We are used to having to make sure that when we find the area of a triangle, it's either a right triangle, or if it's not, then we have to make that triangle into two right triangles and then use our right triangle trigonometry. For example, I can take this triangle, it's not a right triangle, draw in the altitude, and if I know enough information, then I can use SOHCAHTOA to take me through the process of finding the altitude. We've also done some where our triangle was actually on a grid and we were able to maybe count the base and the height, or create right triangles that helped us find the base and the height, and it was a little bit easier. Lately, we've been seeing triangles that are not always going to have a base and a height. We've been solving triangles using the law of sines and the law of cosines. And today we are progressing into finding the area of these triangles when I maybe don't have enough information to create a right triangle, or that's just not the most efficient method, that there might be something that is easier that I can use to help me find those areas. So we still have our very handy 1/2 base times height. Most of the time we see that in right triangles. If I'm given a base with a perpendicular height, then I can use this formula. If I'm not, there are two other formulas that will actually help me find the area of a non-right triangle, or a triangle of which does not have a perpendicular base and height. So I have the side angle side formula. The thing with this side angle side, there are 3 different formulas. Don't forget the little letters represent our sides, our capital letters represent our angle measures. It must be a side angle side triangle, meaning that the triangle you are given, you must know the sides and the angle between. That's what you must know. The 2 sides you're given, you must know the angle between, which is why if I set up a triangle for labeling it as my formula is, with A, B's, and C's, I can now go through the process of identifying, okay, what sides am I given? What angles am I given? Am I given enough information to use side angle side? Or, sorry, am I given enough information so I have a side angle side triangle? So if I have side CB, angle A is between CB. Side AB has angle C between them. Angle B is between C and A. So it needs to be an angle an angle that is between the 2 sides that you are given. And then our third formula is Heron's formula. And this formula is specifically for side, side, side triangles. So I would be able to use this on a triangle that I know all 3 side lengths for. With this formula, you must find S first, and S represents the perimeter of your triangle divided by 2. So just like all these other formulas, a triangle is half of a rectangle, and if I put 2 identical triangles together, they will always give me a rectangle. 1/2 base times height, 1/2 my 2 sides times the sine of the angle, and here it's 1/2 of my perimeter. So you do have to find the perimeter of your triangle first, then you can go through and use Heron's formula. So I have 3 examples here. We need to pay attention to what we are given, make the decision of which formula would be the most efficient, and then use that formula. Now, since you are going to be asked to find the area of triangles that you may have already solved, you then have the freedom to kind of choose between the side angle side or the side 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 formula, whichever one you are most comfortable with. Please make sure that you pause when you need to, that you have a calculator with you. Practice going through these at the same time. Pause it, copy this triangle, maybe try it on your own, and then play the video to see if you did the same thing and you got the same answer. All right, so in this one, I see that I am given 3 side lengths. So I'm going to use the side, side, side formula. So the first thing I need to find is S, and S is the perimeter. So 7 plus 6.8 plus 5.2, all divided by 2. So in my calculator, when I do this, 7 plus 6.8 plus 5.2, I get 19 divided by 2, which is 9.5. So now I could plug into the formula for area. 9.5 times, now it's going to be 9.5 minus my all 3 side lengths. So I have to do this 3 different times. So my first side length I'm going to use is 7. Then it's 9.5 minus 6.8 and 9.5 minus 5.2. So I need to find all of that. So now I'm going to have my original 9.5. So 9.5 minus 7 is 2.5. 9.5 minus 6.8, 2.7. And 9.5 minus 5.2 is 4.3. Now I'm going to multiply all 4 of those numbers together. 9.5 times 2.5 times 2.7. Please be careful when you're plugging in times 4.3. You don't want to make an error, accidentally hit the wrong number, so pay attention to your precision and your accuracy with typing in your numbers. When you multiply all 4 of those together, I get 275.7375. That's where the decimal ends. Now I'm going to square root that answer. So I'm going to square root, leave the decimal in my calculator. My area is 16.6053. Now I want to, and there's more to it, I want to round this to the hundredths place. So that's 2 decimal places. So I look at the third. 5 is going to round the 0. If it was less than 5, it would not round the 0 and it would stay at 60. But the 5 is going to round my 0 to a 1 units squared. I do not know the units. There's my area. If you need to pause, watch this again, fine. You do have a lot of practice in your RSG on using this formula. And there are also more triangles that you guys can practice this on the video, or sorry, the worksheets that are on our website for Module 5. So you can check those out and practice. Example 2. So write this triangle down, pause it. I'm not going to wait. This is a right triangle, so I'm actually going to be able to use 1/2 base times height, but your base and your height must be perpendicular. So it's these 2 sides that you need. Those are the perpendicular, but I'm missing that side. So what can I use to find a missing side of a right triangle? Oh, I can use the Pythagorean theorem. So I can use a squared plus 10 squared equals 14 squared. So I'm going to go through, I'm going to do this in my calculator. I'm going to move the 10 squared over. 144 minus 100 is 44. Now I'm going to square root that. So A, and I'm not showing you guys this, you should be fine. 6.63 when I round it. So now I have my base and my height. So my area, my base is 10, my height is 6.63, and I'm going to divide by 2. You could divide the 10 and the 2 and just use 5. So 10, I'm going to leave it in my calculator since I know that's what most of you will do. 10 times 6.63. Do not use the whole decimal here. Once you identify a side length as being a certain length, we talked about this in class today, Once you identify that as being, oh, it's 6.63, just use 6.63, please. Do not use the whole decimal. Then I'm going to divide by 2, and my area is 33.15 units squared. All right, let's move on to our last example. So here, let's see. I don't have all three sides. This is not a right triangle, but I do have a side, and an angle between. This is a side angle side triangle. So 1/2, it's side times side. So our formula uses A's and B's. C's, that's okay. It's side times the sine of theta. So in this case, our theta is the 99 degrees, and our sides are 15 and 14. So making sure that your calculator is in degree mode. 14 times 15 is 210. So this is 210 times the sine, sorry, almost forgot the n, of 99, all divided by 2. So 210 times the sine of 99, and then divided by 2. And you don't have to use the same process as I'm going through as far as the calculator is concerned. You can do 15 times 14 divided by 2, hit equals, and then times the sine of 99. That works as well. When I go through and finish using my calculator, I have 103.707. So the 7 will round the 0. So 103.71 units squared. So you got to look at all three formulas being used. If you need more help, I will be here after school. Come in and get some help. If you have questions, you can ask them in class. And I hope this helped. See you then.